Hi, I am Kent Lennartsson. I'm the research manager at Kvaser AB. I and Lars Berno founded Kvaser in 1985. Our first CAN product was launched in 1989 based on the Philips 82C200 and Intel 82526 CAN controller. This is a short overview of the CAN technology and the functionality of CANFT, important for the future CAN applications. We start with a quick history of CAN. The CAN protocol was first defined in mid-1980 by a team at Bosch led by Uwe Kinke. CAN was presented before a broader public in 1987 as the future data communication standard to be used by the automotive industry. The CAN protocol has some nice features optimized for real-time control systems. By 1989, very soon after the first publication, Dornier, a manufacturing of weaving looms, was using CAN in the air-jet weaving machines. The first automotive application of CAN was in the Mercedes S-Class 1993. Here is a simplified animation of a car. A driver expects a direct response to any input, like controlling the headlight. It's not good enough to be responsive in 99.99% of the cases. The driver expects the car to respond accurately each and every time over the car's entire lifetime. A communication delay would be as bad as having air in the brake lines. In this simplified view of the car, there are 4 control units. One at the brake pedal, sensing how hard the driver compresses the pedal. One at the front wheel, braking, one for a rear wheel braking, and one for displaying the braking condition to cars behind. All control units are connected together by the data communication bus line. By 1973, Ethernet was already running at 3 megabit per second. Today, Ethernet supports speeds of 10, 100, and even 1000 megabit per second. There is a certain probability that 2 units will start sending an Ethernet frame at the same time. This will result in a collision, and the sending process will stop. All units wait a random delay time before they restart sending. If, after such a delay, collisions still occur, the random delay time is increased, until one unit starts sending before all other units. Ethernet is very efficient as long as there is no collision. If the bus load is high, the transfer delay can increase significantly due to collision. There are solutions where additional rules can be added on top of the Ethernet protocol to reduce or even remove this problem. With CAN, collisions are solved without any delay. In CAN, every package has a priority level. There can be up to 53 million different priority levels in CAN. In this example, we only show 4 levels. As soon as there is no traffic on the CANbus, any unit can send a package. At this point, CAN function is the same as Ethernet. The difference occurs when there is a collision. In CAN, the collision can be resolved in real time, because the highest priority package will be sent first. There is no priority between the different units, and a unit can send package with different priorities. CAN is designed in such way that no bit is corrupted during a collision. This makes it possible to have 100% bus load without causing any delays. The cost for this nice feature is a bitrate below 1 megabit per second. With CANFT, it is possible to increase the bitrate from 1 to 10 megabit per second, still without any delay caused by the collisions. Here we have one of our products supporting CANFT. In this case, it's a PCI Express board with 4 CANFT controllers, all 4 in this Altera FPGA. Such a board is installed in this computer here, running a CANFT application, and the bus from that application is connected to the oscilloscope over here, where we can see a classical CAN frame with 8 bytes of data. If we switch to CANFT, we will see that the length of the message decreases to 20% of the classical CAN frame. CANFT also supports 64 bytes of data. And you can see here how we increase the number of bytes from 8 to 64, where the CANFT frame becomes longer. Still, the CANFT frame is only 50% of a classical CAN frame with 8 bytes of data. In coming videos, we will describe how CANFT provides this higher bitrate and more data into the CAN frame. Good luck now with your CANfd projects, and if you need more information, go to our homepage, kvaser.com. Hope to see you soon.